In this example, we want to find the 35th term in the arithmetic sequence 3, 9, 15, 21, and so on. To find the 35th term, we are going to use the formula below, where we have a sub n equals a1 plus n minus 1 all multiplied by d. So in this question, we need to find the 35th term. So that means we're solving for a sub n. So therefore, we need to find a1, n, and d. Let's find all these by writing out our arithmetic sequence. We have 3, 9, 15, 21, and so on. Because 3 is our first term in our sequence, we know that 3 is going to be a1. 9 is our second term, so it is a2, and then so on. So because we know that 3 is a1, we just solve for one of our unknowns where a1 equals 3. But we still need to find n and d. Well, n is whatever term we're solving for. We're solving for the 35th term, so therefore n is going to equal 35, as given to us in the question above. Now what we need to find is d, which is the common difference. To find d, we need to ask ourselves, what do we have to add to get from 3 to 9? Well, to get from 3 to 9, we have to add 6. To get from 9 to 15, we also have to add 6. And then to get from 15 to 21, we also have to add 6. So therefore, the common difference between each of these terms is 6. So d equals 6. Now that we know a1, n, and d, we can solve for a of n. Because we need to find the 35th term, instead of writing a of n, we can write a of 35, because a of 35 is going to be the 35th term in the sequence. So a of 35 equals a1, which we solved to be 3, plus n, which we found to be 35, minus 1, all multiplied by d, which is 6. So now all we have to do is algebra. We first want to do inside the brackets first. So we still have a of 35 equals 3 plus 35 minus 1, which is 34, all multiplied by 6. And next we have to do multiplication. So 34 multiplied by 6. So a of 35 equals 3 plus 34 times 6, which gives us 204. Now what we're left with is 3 plus 204. So a of 35 equals 3 plus 204, which is 207. So therefore, our 35th term in the arithmetic sequence is 207.